it's a shame I had to cut that song short. I really like it. So, good evening everyone, and I'm really happy to see you. Well, I don't actually see you, I do see you on chat, so I kinda see you. I hope you're happy to see me, because today we are going to do even more PicoCTF. And today's moderator is going to be KrzaQ. You can see his nickname right here, which means that if you have any questions for me, then do let KrzaQ know, and he will be able to grab that question from whatever chat you are on. You might be on YouTube chat, Discord, or our IRC, and then put it on my question panel, and then I can go back to that question at a later stage. I will look a bit on the chat, but usually I'm pretty focused on the task I'm doing, so yeah, that's why you actually have to message KrzaQ to get the question in. Now, if you're on our IRC, what you can do is you can also do an exclamation mark Q and then the question, and a bot will grab your question and also put it in the question panel. Okay, so as usual, I guess I will start doing PicoCTF around 15 past, a quarter past, and before that I will do some random announcement and answer some questions. So let's get started with announcement part. Okay, I did have a browser, here we go. So this is KrzaQ's website, dev.krzaq.cc, and this is the website of my moderator, which means it's absolutely amazing and you should visit it. There we go. Now, if you are on our Discord or you are following me on Twitter, you know that I've started posting some like simple to less simple web challenges, because I'm basically learning Node.js and Express.js, and every weird thing I find, I'm just making a challenge about it. So yeah, like the first challenge is here, and just like go to my Twitter account and check it out. On the other hand, there was also a second challenge posted, which is a little bit more fun. I actually even made a DNS entry for that host. Anyway, if you are on our Discord, then you know there is a channel which is called challenges or hash challenges, and all these things and many more challenges are posted there. So yeah, just join our Discord, hang out with us, and you can get the challenges early, since I'm posting on Twitter rather, well, later, I guess. Now, yeah, this is like fresh news from, I don't know, like few hours ago actually. Yuru posted that he found no interaction required MMS-only remote code execution on modern Android Samsung phones released after 2015. And there's even a demo, even a recording where actually like the video is pretty short, but if you read the timestamps, the actual exploitation takes a couple of hours to, I guess, brute force ASLR. And yeah, like the phone shows like it receiving some messages, and after some time, like the attacker gets a shell on the phone, which is like pretty amazing. And Yuru released quite a lot of tools that he wrote and quite a lot of information. So, and there's already a fix for that. So if you have a Samsung phone, I actually have a Samsung phone, so I'm waiting for my update, notification to pop up any minute now. And yeah, he released basically like the link to the update. He released then the tracker bug entry on Project Zero tracker. Then he released the actual fuzzer. This is like a specialized fuzzer that you might want to look at, and he's saying that there will be even more stuff released on Project Zero with a description, I guess, of more details. Now, what I really liked, like this is a specialized fuzzer. Like if you want to see a real fuzzer, like which finds real O-days and amazing bugs, read this basically, and take a look at this. And what's fun, and I actually really liked, was this part at the very bottom. There is a note about because this is a bug in image format. The bugs are always in image formats. Image formats are terrible. Well, not image formats per se, but the libraries implementing them. So yeah, he says that there's like this QG image format, and there is a version 2.0, but he didn't find any files. Anyway, the fuzzer found something with this header, which is supposed to be a non-existent format QG1.2, which doesn't exist. Like there is like, I don't know, no specification, no support for it. But due to the parser, how the parser was implemented, it seems that pretending to be that format actually provided functionality which is equivalent to 2.0, but bypasses some checksum verification, which makes it easier to fuzz. Which is, yeah, like, exactly, behold the power of coverage guided fuzzing. This is amazing, like an amazing find. Like, basically the fuzzer created a file which should not exist, which according to the specification does not exist, but it actually like helped with fuzzing because it put the parser in a pretty weird state where some features were taken from this version, some features from that version. Amazing stuff. So do check it out. If you don't follow Yuru on Twitter, you absolutely should do that. I will give you a link to this as well. I already gave that link on Discord today, so if you're on our Discord or on our IRC, then I guess you already have a link, so I just posted it on YouTube chat. Now, what else do we have? Oh yeah, you remember last week I was basically playing with a heap exploitation challenge, and the heap part wasn't the problem. I was kind of afraid it will be the problem, but it wasn't the problem. The problem was that, which I got stuck on for 1.5 hours on the live stream, was that for some reason my payload was being sent through a terminal and some characters were missing. So after the live stream I actually started digging into it, like what was the problem. So it wasn't Python 3, it wasn't even the PTY library in Python, which I actually suspected that was the problem, because then when I switched to OpenPTY, to os.openpty, that actually worked well, but pty.spawn did not work correctly. Now, I kind of misunderstood how PTY spawn, what is it supposed to do, but that wasn't the problem either, because I used it in a hackish way, but correctly to what I wanted to do. Now, yeah, so I basically like started to dig into it, and what I found out, so this was basically the scenario, and the problem was that we needed to use the terminal device instead of using a pipe, because the application put an address which we needed to read, like the application which we were exploiting put an address which we needed to read from standard output on the standard output, but it didn't flash the standard output if we connected a pipe device to it. So we had to connect a terminal device to standard output, and according to the default GNU C library behavior, that actually, it fell down basically to here, to this case, where it flashed automatically standard output only after outputting 4 kilobytes. And 4 kilobytes is a lot, and it just outputted several bytes, so it was never flashed. We never got to read the address. That's why we had to actually connect a terminal device, a PTY pseudo terminal device, which flashes at every new line. And yeah, so yeah, what we did is we used this one at the beginning, and then I switched to this one, but this doesn't matter. They actually work identically. This actually calls this one, and that wasn't the problem. I used this in a weird way, that's why it worked, and I will get to that in a second. And what we found out after 1.5 hours is that when I had a child process and my pseudo terminal was connected to the standard input, and the standard output of errors was connected also to the pseudo terminal, so I could read the data, I found out that whatever I sent to standard input, then these bytes were missing. Like all of these bytes were being eaten, processed, whatever you want to call it. And what I did in the end is I basically created a pipe, and I also created a pseudo terminal, but I connected the pseudo terminal only to the standard output and standard error of the child process, and I created a pipe for standard input. So no terminal, no problem, I could just send the exploit, and the exploit worked like first try, right? We did a test run, and that worked. Now the actual proper solution was to use this, like just do this, and my problem, or rather my mistake which I made, is I assumed that the terminal after being created is in the raw mode already, and this is the assumption I was working throughout like all the time. That's not the case. Actually, after the terminal, after the PTY device is being created with like OS Open PTY or like whatever other API you want to use, it's set in so-called canonical mode. And in canonical mode, it processes some of the escape, like terminal escape sequences or terminal control characters, whatever you want to call them. And that is exactly what caused the missing bytes. So the bytes were sent from our parent process, but the child never received them because the pseudo terminal just ate them. We just like reset it, like set the terminal into non-canonical mode. We can do it on master, we can do it on slave, that doesn't matter, and everything works. So this is the proper solution, which I should have used. Like I could still use this scheme with like just without any pipes, just set master, which would set the whole pseudo terminal device into raw mode, and in raw mode, that's it. Like no characters are being processed, everything is being just sent to the child. Oh well, the more you know. Yeah, so before we get here, how many challenges do we have unsolved? It says 21, but I'm pretty sure we have more than 21 challenges unsolved. Let's take a look if there are any questions. Okay, and if you have any questions, you need to ping KrzaQ, because KrzaQ will put the question in my question panel, so I can show it to you here, as it should appear in a second, and then I can answer it. So Keshav asks, do you think CPU getting rid of 32-bit instruction would make CPU faster, as more silicon is allocated to other parts? Not necessarily. So it's like this. Certain operations take the larger the register size is, the more operations, the more cycles the CPU needs to spend on it. And that is true for like multiplication, division, and everything which is more complex than that, you know, like powers, like square roots, and so on. So 32-bit multiplication is basically faster than 64-bit multiplication. And so that's one thing which should be taken into account when considering this. And the second thing is memory bandwidth. Because if suddenly all your variables are 64-bit and you have to operate on 64-bit variables because your 32-bit variables are gone, then you need twice the memory bandwidth basically, because still currently like most variables are 32-bit, which are stored in memory. Not all of them. Pointers need to be 64-bit obviously, but like, you know, you create this I variable for a loop that's going to be an integer. It's not going to be a 64-bit integer, it's going to be a 32-bit integer, and so on and so forth. So the amount of memory would actually increase, and therefore you would get hit at the bandwidth, because the bandwidth would not increase with the RAM, with the caches, and the cache size would also not increase. So there would be a problem there, and you would be forced to use larger variables, more data through the same bandwidth, and larger variables in the same mathematical operations. Granted, there are not many multiplications and divisions in most applications. Like a lot is just like simple additions and stuff, or multiplication like with powers of 2, which is super fast actually, because that's just bit shifting. And that's it. If you mean removing the 32-bit mode of a CPU, then I would argue that there isn't that much that would be removed, because the instructions are pretty much like, I'm pretty sure the implementation of a 32-bit and 64-bit. Okay, so it's like this. You can still keep 32-bit variables in 64-bit mode, but remove like 32-bit and 16-bit modes from the CPU. That would save some silicon, especially around, I guess, like memory controller and so on. But not that much. I think not that much. But might depend on the actual CPU architecture we are talking about. But that would depend on because, you know, ARM also has like 32-bit and 64-bit modes and so on. But yeah, it's Yeah, it might free some silicon up, but I'm not sure if we would get any performance gains on that. Or like large performance gains, or if we could fit in another core. I don't think that's the problem, actually. So it's a super interesting discussion to have, I would say. But I don't think we would get that much out of it. It would simplify a little the, I don't know, like the Verilog code or whatever Intel uses internally to make the CPUs. But that's about it, I guess. It might, like, because of the simplification, there might be some benefits to security. Yeah, like, that's an interesting topic for discussion. Okay, I think that was actually all the questions. I did see one question on the chat. How did I learn assembly? I learned assembly. Yeah, don't learn assembly the way I learned assembly, basically. I learned assembly having like a small book with some. It was basically a list of instructions plus how to use a DOS debug.com tool, which is a debugger, to compile assembly and create .com files. And that was an ill-fitting tool. You could use it, but it was basically a hack to use it. And the instructions were written, like the description of them had some bugs, had some issues. So I was stuck on some instructions because I absolutely had no idea what an instruction does because it was just described incorrectly. And that was my first attempt, I guess, at assembly. But yeah, I somehow like managed to power through it enough to understand some basic, like how to move stuff between registers, how to add stuff. And then at that time you could use in Turbo Pascal, which I was coding at that time, you could add assembly inline, and that inline assembly would interact with Python variables and so on. So you could just like create a variable and then use it in assembly, and then just like more Python code, which was a pretty simple way to learn more about assembly operations. And you can still do that in I believe in GCC. However, GCC syntax for inline assembly is painful, like absolutely painful, and I wouldn't recommend doing it like that right now. So yeah, that was ages ago, and I wouldn't go that way, basically. Yeah, like when learning assembly is basically like you need to do three things. You need to select an operating system, select the CPU architecture first, I guess, and then select the one assembly compiler or assembler which you are going to use, and then find a tutorial or a book or whatever for that, for the tuple of three things: architecture, like CPU architecture, then the operating system, and then the assembler, the compiler. Because otherwise, like, you cannot learn x86 assembly while looking at an ARM assembly tutorial, because we have different instructions, different way it works, and so on. If the operating system changes, then even if the same assembler might be used here and there, it's like Windows, for example, and Linux have totally different way they approach interacting from a program with the operating system. If you want to output something, it's totally different on Linux and on Windows, and you do it in a totally different ways. So that's why you need to select an operating system which you will be focusing on, and then the assembler, the assembly compiler, because the syntax differs a little, slightly. Sometimes more, sometimes less, but it differs. Especially, like, even if the instructions are the same, then the compiler directives, macros, and so on, that will be different in different assembly compilers. That's why you need to select each of them and then find a tutorial for that. That's basically the way to learn. So that's one thing. The other thing, if you know already C or C++, or just the basics even, that's enough. Even if you know the basics, that's enough. Go to a compiler explorer, and which would be, we can, I guess, just to do, that would be godbolt. Godbolt.org, that's compiler explorer. And yeah, whatever code you are going to type here, you're going to get the assembly equivalent of it here. You can have it optimized or not optimized. This is a not optimized, easy to read version. And yeah, just like take a look, like what do you want to do in assembly, write it in C and then see how it's compiled, and then like try to write your program by looking at this, by looking at the tutorial, and yeah, and try to achieve what you want to achieve. Yeah, that's basically what I would say. And also have a list of instructions for the given architecture at hand all the time. In case of Intel, that would be Intel Manuals Volume 2, which you can just download, like Intel Manual Volume 2. And here we go, it's just like first result at Google. I would actually recommend downloading it instead of viewing it at the browser, because it's like 200 pages. And if you open it in something sane, like, well, sane for viewing PDFs, but sane isn't the good word here. If you open it in other applications than Chrome, then you get a nice table of content here with all instructions and so on. And each instruction is described in detail. Let's find some non-weird instruction. Are there any non-weird instructions here? Blah, blah, blah. Let's look for push. Yeah, there's push. We click on push here, and it shows you all the possible variants of push. You need to learn this notation. What does this mean? It's easy. Once you get it, it's super easy. Don't worry about it, but you need to learn it. You can ignore this unless you're deep into reverse engineering. These are basically how is the instruction encoded. Then there is the description. You can usually ignore the description. What you are interested in is the operation part, which, yeah, if you're like on 64-bit, you basically look at this part only stack size 64, and then take a look what's going on. For example, here, the push is actually, it decreases the RSP register by 8, and then on the memory address of RSP in the stack segment, you can ignore the stack segment in 64-bit, this is like just going to be the same as all other segments. It puts whatever the source operand is, whatever you're pushing on the stack. And this is the pseudocode, obviously, but it usually tells you more than, well, if this doesn't help, you can read the description. That's basically the way I use it. Then there are some other like flags affected, what kind of exceptions you might get if everything fails. And you, like, there's a lot of text which you can ignore. And yeah, and just focus on this and focus on the operation. This is the first thing you look at. And do get to know how to use Intel Manual Volume 2, because it's your best friend. If Intel Manual is kinda hard for you, you can try AMD manuals. AMD also has manuals like that with a list of instructions. And some people prefer it, so you might want to check AMD manuals as well. Okay, so 2 more questions and we get to the actual next PicoCTF challenge. Which tools you use to create that PDF presentation about PTY? Google Slides. Yeah, I basically always use Google Slides nowadays. Dashin writes, is it beneficial doing coding in white paper or whiteboard? Oh, you mean like coding on paper on a whiteboard? I guess it's a question a bit about, at least I'm interpreting it in a way like, yeah, on a job interview, they might ask me to code on the whiteboard or code on a piece of paper. Should I train it? I would say no, because if you code a lot, then it doesn't matter. Like, you will know coding by heart at some point, and then like if you write the code on a piece of paper, if you write the code on a whiteboard or in a text editor, it doesn't matter for you. You will just do good in either case. You might want to, if you've never done it, just like practice, write a simple program and see if you like it. I know a lot of people don't like it, and that's fair. I don't mind personally, because yeah, I know coding by heart, so I don't mind writing on a piece of paper. It doesn't matter to me. But I wouldn't train it unless it is really a problem for you. I wouldn't train this skill. Just code in an editor and write and run it and see what happens. That's more beneficial. How do you manage to stay focused on one discipline in InfoSec, for example, reverse engineering, without getting distracted by new stuff coming in other areas, like new red team techniques and so on? I have no idea. I am constantly distracted by stuff. I do a lot of different things, from programming, through reverse engineering, through low-level security, web security, to some other stuff, which like simple graphic design, reviewing articles, or writing books, right? So yeah, I don't know, because I'm not focusing on one thing. I'm always distracted with different fields and different stuff. You have to ask that question to somebody smarter than me. Cool. Okay, let's get going with the tasks in that case. Again, I'm ignoring forensics for now, because this is sound and I still don't have my setup so you can hear the sound. And yeah, and I don't hear the sound and you don't hear the sound again through the microphone. It's complicated. Empire 1, web exploitation 400. Let's play with it. The description, Sid, agent 513, now that you're an employee of the evil Empire CO, what's that, like company? Try to get the secrets of the company website, and this is the link, like I guess it's an external link. Can you find the secret code they assigned to you? Or we also get like a different link, but let's play with this link first. Welcome. This website is guarded by sharks with lasers. Okay, we are in trouble, folks. Employees, please log in. Everyone else, please leave. And we can register. Well, okay. Log in. Let's log in. I cannot log in because I need to register. So let's register. ASDF, name ASDF, password ASDF, confirm ASDF. Here we go. ASDF. And what can we do inside? Things you got to do. Your to-dos. Okay. So now, I do remember this task. I actually have done this task with a friend of mine. So what I'm going to do is I'm going to show you how to solve it, and then I'm going to show you the exploit of my friend, because he kind of approached some parts of it a little different than I, and it's always a learning opportunity for us. So what we can do is we can add a to-do, like let's say learn XYZ, and click create, and then when we can create another to-do. Perfect. Go to shop. I know it's go to a shop, but whatever. Yeah, and then it shows up here. So that's nice. The question is what can we do here? I'm going to take a look first if there are any cookies. What kind of cookies do we have? And what exact path is of a cookie? There's some session here. The session looks like a typical session. I'm not going to play with the session yet, because on a lot of, I guess, a lot of challenges, the session isn't really that important. We can take a look, try to take a look what's here, but yeah. What kind of application is this in, by the way? It's in... doesn't say, just say Nginx. So it says Nginx, which might mean it's either PHP or it's probably not PHP, or it's like Python Flask, or it's something else, but something which has Nginx at the front. Cool. So I said that we are going to take a look at the session, but just for a bit. So I'm going to launch Python. I think I installed IPython actually. Yeah, I did. Perfect. And I do need nodes. How was it called again? Was it like Empire 1. I do need nodes. Here we go. Let's make it a bit bigger. Now, this is, what is it? This looks like base 64, but it's one of the web encoding forms. If you go to wiki base 64, this one, then there are some there are some like different encodings of base 64. For example, the typical URL safe encoding uses these two characters instead of these characters. So yeah, if we like change, then we can just decode it. So I'm going to change the minus to a plus, so minus to a plus, replace, and then change the underscore to a slash and replace. Did it replace all? Yeah, I think it did. Okay, cool. And now we have these dots here. I'm taking this as some kind of a delimiter, like a separator basically. So I'm just going to separate it. And I'm guessing this is the part which is the actual data. We can take a look if we can decode it. So I'm going to put it in a string. I'm going to, I guess, do this, and yeah. And now I'm going to import base 64 and base 64, B64, decode, and that would be out too. And it decoded it, but it looks like totally like garbage, which means this is probably encrypted. And yeah, so let's not go this way because the session is probably encrypted. We might need to brute force the encryption key, but let's not go there yet. Like, this is something, let's leave this open in our mind, but one branch of the potential solutions is to try to decrypt the key for that. But I'm not going to do that now, so instead I'm going to play a little bit with this input here. I guess the usual thing is, you know, like try SQL injection, right? So this is like put some, I'm going to put like a single quote, a double quote, can we make it bigger? Then I'm going to like do this and type ASDF and let's see what happens. And it says internal server error, how nice. So it means it's some kind of injection probably, and it might be SQL injection. This is pretty common in, especially like in websites, right? So which of these characters caused the error? Let's start with a single quote because it's at the beginning and it's, yeah, it causes the error. Let's do the second character, that would be a quote. A quote does not cause an error, and let's use the triangle bracket. The triangle bracket also does not cause an error. So let's take a look at to-dos. Yeah, we have the triangle bracket, we have this, so that's fine. So now, yeah, let's do this, what it actually suggests. Let's just do a concatenations of two things, because I don't know, but this is probably like some kind of SQL, right? So we have some query, I don't know, like select, ASDF, XYZ, from whatever, we have no idea where, I know it's actually an insert, right? Insert into, because that's not a select, that's an insert. Into wherever. I have absolutely, I don't remember like the actual syntax. I think it's into whatever, and then I think there are the fields, so I don't like to do, and then the values, and the value would be, and here is like our input. This is how I see this query. It might be something different, but this is how I'm going to assume for now what it looks like. So the input I'm going to, yeah, let's change the input to this. So it actually should just give me, I guess, an empty string or whatever. Let's see what happens. Create, yeah, it didn't crash. It's important, it didn't crash, so it might not even be SQL at this point, but it didn't crash, so this is a valid hypothesis. Still, we are not going to say, yeah, okay, this is weird. Why is it 0? We gave a plus, maybe because of a plus, something is going under, so the plus is actually doing something weird. That's pretty weird. Okay, so if we don't use a plus, what do we use? Or like, can we do a minus? What will happen if we do a minus? I'm pretty curious. Quote minus quote. Let's see. Item added, and it's a single quote. I'm getting confused now. So this gave us a 0. This gave us just a single quote. What if we do this? It gave us also a single quote. Okay. What if we do like plus? Oh, I see I have like some, this is, I don't know, is it from this side or is it from the other side? Let's just clean it so it's a little bit cleaner. How do we clean it? Autofill. Passwords, payments, addresses, and more. Clear browsing data. Autofill data. Is this like from clear form data, form suggestions? Yeah, that's what I wrote. How to disable or clear autofill. Okay, so just go for it, like disable the autofill. Okay, let's see if this works. I'm going to refresh. Yeah, it works, perfect. So we can now play with it a bit more. What I was going for is like, let's do like this +7 here. And +7 did, oh, we got a 7. So this is some kind of a mathematical calculator, I don't know, which is weird, right? Because we just put a string and it's all fine, and then suddenly it like seems to, if we use a plus, it seems to actually convert it into an integer. Maybe the plus here is the problem. How else can we actually concatenate a string if the plus is a problem? What kind of SQL is this? Like MySQL concatenate a string in insert. Okay, yeah, this is basically what we want to do, and it says to use concat, but yeah, I guess we cannot really use a concat here. So yeah, okay, this might be the problem actually, but we cannot use plus to concatenate two strings. What happens if we do, we close it, then we do like, I don't know, 2 spaces, and we open it and do ISDF. And it says internal error, so that doesn't work either. Can we use a dot, for example? Yeah, we cannot use a dot. You're saying that an @ sign, okay. @ sign and 0. No, so @ was interpreted actually as a bitwise OR, it seems. Okay. As the SQL concatenate two strings. SQL server uses concat. It also requires a function. Can we do it without a function? This uses plus, but we know plus doesn't work for us, so that's not it. Concatenate, no. Oh, it says to use the two pipes. 2 pipes, ASDF, 2 pipes. Okay. And it actually worked. Yeah, and it worked. So it's probably it. That's probably it. What kind of SQL was it? This. How to concatenate two strings in SQL, and we found that this worked. So it might be Oracle, or Postgres. Maybe it's Postgres. Any other option? No, it's either Oracle or Postgres according to this, but yeah, I don't think, like, there are only a couple of SQL servers here, so it might be something else as well. But okay, we know we can use this, so if we can use this, what can we actually do next? Can we do like this? Sorry about that. And then do a select, like select XYZ, let's do A here. I don't know if I need to add it, let's add it. Let's just add by brackets and then B. And let's see if this works, if we can actually inject something here. It didn't crash, this is a good sign. And yeah, it works, we can inject select. Now, it might actually not work. What might actually be happening here is it might start to remove characters. If it, for example, sees a pipe, then it starts to remove characters which aren't small letters. But to do that, I guess we can, what can we do? I don't know, can we SQL to upper? We can, where's an upper function? So let's do upper here and see if it actually executes it or if it's some kind of weird filtering which is kind of playing with us. So do this, it didn't crash. No, it works. Because the upper works, it did convert XYZ to uppercase. So okay, we have code execution, basically SQL code execution. So yeah, now we need to get stuff. And what do we need to get again in this task? We need to try to get the secrets of the company website. Perfect. Secret code they assigned to you. Okay. First thing I want to know is like which version of like Oracle or Postgres is it? So Postgres version. Postgres version function. Postgres how to check version. Yeah. This is not what I want. Select version. Okay. So we are going to do a select version and we are going to take a look what's going on here. Yeah, kind of wrong form. Internal error. Okay, so there might be no version function. SQL injection check version. Let's see if there's like a cheat sheet. This is exactly what I was looking for, a cheat sheet which would tell me how to check the version in multiple different version detection. Yeah, just show me like version. Same as version. Let's take a look at this version thingy. Internal error, so that doesn't work. Okay. How else do we? How else do we check the version? Okay, I think that was actually it. Find out the version, then there's this like... Okay, so it's not Postgres, we know this is not it. Okay, select banner from where banner like Oracle. This is weird. Let's try it. Let's see if this is actually Oracle. I think this is supposed to be like this though. No, that's not it. Okay, so that might not be Oracle actually. And this doesn't really work, like, this is weird. I would expect this to work. Okay, what engines are missing here? SQLite. Check version. Okay, yeah, well, this is a little different name, so let's try this one. This is a function, right? It's correct, it's a function. Cool. Oh, it didn't crash. It's SQLite. Yeah, it's SQLite with this number, so we know it's SQLite, which is a pretty popular database right now. Is it an old version or is it a new version? Let me take a look at wiki or whatever. Here, yeah, it seems not super new, but it's actually like decent. And the version numbering is pretty close. This is like 3.31 and this is like 3.220. So yeah, it's not super out there, but that's fine. So how do we live? Okay, we are kind of operating blind here. We have no idea to what table we are writing. We have no idea what are the fields names. We can try to guess like username maybe, but instead of guessing, I would like to get the information from like, is there an SQLite something like information scheme? So SQLite information schema. Yeah. Information schema is like typical metadata which Oh, there's actually something called SQLite master, it seems. Okay, let's play with this. I actually didn't know that. I don't think I exploited SQLite before. Yeah, I don't think I ever did this for SQLite, what I'm doing right now, which is fine. Cool, so name, blah blah blah, table, and we need to limit it by 1, because we can only get one string, right? If we get more, then concatenation stops working. Because you can concatenate with a string result, but you cannot concatenate with an array of strings. Didn't crash, that's great. To do. I think we can lose the AB. Okay, so we know we have a to do. Then we get limit 1, sorry, 1, 1. I think 1, 1 means like show me only 1, but start listing from the second one. Or it should be 1, 2, I don't know, let's just see. Your to-dos, user, okay, so we know there's a user. And then we do the same. But we change this one to 2 or the other one? Yeah, this one. User, no, the other one. Anyway. So it should be 2, 1. Okay. None. Okay, so there are 2 tables. It's called to do and the user. We need to find the secret code which is assigned to our user. Therefore, we care only about the table user from now on. I have no idea what kind of fields are there in the table user. I'm guessing like just doing this will fail. So SQL master, can I actually like column? How do I display columns? Column. SQLite master, column names. This is what I need. Yeah, I could look at that probably in the documentation, but whatever. So table name is and type is table, and we get, I guess we get a column. Yeah. So this is what we need. We know that the table name is going to be user. The type is going to be table, yeah? Okay, we still need the limit. So we put the limit. I'm not sure if we need the brackets, but I'm just putting them for safety. Okay, SQL master where table is used. Okay, that's pretty interesting. Because we are using the same table. In information scheme, that's actually not the same table. Oh well, add a to do. And none. Okay, so what did I do? It's quite nice from it, but it actually says none, and it does not say, like, yeah, you're stupid, go away. Table user and type. Maybe this type table, like there's some problems with it. So I'm going to remove the type table and add the to do. And oh yeah, I create unique index on user. What did I just get? I have absolutely no idea what I'm looking at. I'm just going to copy it. Okay, let's see what the second thing is then. None. I'm not sure this is exactly what I wanted. Table user. So maybe let's look at table to do. Maybe the code is in the to do for some reason. Yeah, I think I'm failing somewhere. This table name, I don't like it. Let's go back to the how to get a list of columns, blah blah blah. I don't like using this. Can we actually use this? Pragma table info blah user. I doubt this is going to work. I seriously doubt. Yeah. But worth a try. Okay. This is weird that this didn't work. Like the previous one was like word type table, SQL master. Maybe I should like have type column or something here. So table name this. No, I don't need SQL, I think. I need column name or something like that. Yeah, I need name. I need here name. This is my problem. Yeah. And I think that's my problem. And this should be fine now. Username, which is fine. This is a good reply. I like that reply. Let's go with the second one. And the second one is none. Okay, well, I'm just going to go for the third one, I guess. Just take a look. That's also none. Can I just do it without the limit then? I can do it without the limit, and it says user. Oh, that's pretty weird. Yeah, that's pretty weird. I don't understand how should I interpret the results. Well, okay, you know what I need? I need actually like a map of this. Show me what is this. Okay, so we have a name, we have a table name. This is not. Is there something like? Something in readable format. So type table, what other types are there? Okay, so we have type, name, table, root page, whatever that is. And okay. You know what? We can actually just like go item by item. It doesn't really matter for us. Let's do this. Show me the name. Maybe I have just to show this one. Oh, actually, let's do it. Show me this one from user, and let's see what happens. Doesn't look like a code actually, but whatever. Internal error. How is that an internal error? Is it username then? Wait, because there are too many users, so I need to limit 1. Still an error. Is the IX in that case? Maybe this is like just underscore separated. Okay, then that's not our user. We need to look for our user. Our user is ASDF, I guess. Okay, can I do like where user name is ASDF? And then show me just one. Okay, and none. There is no user where the user name is ASDF. Okay, I'm just going to continue. 3. Maybe we should just write a script to dump the whole thing. 3 is none. So there are what, 2 users? And okay, what I want to really find out is I want to see if, what is this? Like, is this a field name? What is it? No, it's not a field name. And also what I want to find out is what's going to happen if I'm just going to put an asterisk here. Okay, so it doesn't want asterisks. It's probably the index then. Yeah, you're saying that IX is for index on the chat, I see. What about like 0 in that case? You're saying that 0 is, it's like SQL isn't actually from 1, it's from 0. So let's say not name, username. Maybe this will be our username. And yeah, it is ASDF. Okay, so in that case, if we actually count from 0, then I did make a mistake before here. Yeah, we need to start from, I think I'm like, okay, limit, SQLite limit. Which is which? Which one is offset? Which one is length? Limit, perfect. Limit for, oh, I can use offset. Yeah, this is a great example, like they use the same number here and here, why? This will return only 3 students starting from ID 5. Okay, so this is the offset, this is the limit. Perfect. Let's go again through the same dance. I think we are pretty close though. Yeah, to do, then we go with 1. I'm going to do immediately with add the 2 here. We get to do user none, that's fine. Then we go with type table. We go with those like table name, table name. We are interested in user. Order by name, on the order by nothing, I don't care by what you order actually. And we go with 0 again. So we go with 0, we go with 1, and we go with 2, and we see. Okay, so there's user. Should we check the to-dos in that case? Just to be sure, I'm going to add here like 3, 4, 5, and see if these are just nonce. No. Okay. Let's go with to do. Or did I already do it with to do? Okay, 1, or rather 0, 1, 2, 3, and 4. It's just I'm really confused by this. Like, no, it doesn't make sense. Like, I do not like how what replies do I get. This does not look like what I expect from it. It works way differently than what usually is in the information scheme. Does it have maybe information scheme, or does SQLite not have information scheme? How can we check if there's SQL, if there's like information scheme? Name type. Oh, can we? Oh, that's interesting. Can we just use the SQL here? What does this actually return us? I'm curious. Let's see what this returns us, because the first one returned us what the index. So maybe this will like create something in this index. Maybe this one will return as the actual. Yeah, this is what I wanted. Yeah, this is like totally different than information scheme. I didn't expect to have to get this and parse it. Cool. So ID, username, but we finally have the structure. Name, password. You don't care about the password. You care about the hash. So we need to, yeah, we need to just grab the hash of like, sorry, the secret of some user. So from user limit secret. Cool. And we got likes Oreos. I don't think that's the flag. Let's do this one and this one. I have no idea what our user ID is though. Oh, whatever. Like the third user, it seems it had the flag. So yeah, there we go. Yeah. basically, this was like a standard SQL injection challenge in an insert where we get the echo back basically, and it wasn't bad. Yeah, I kind of like, as I said, I never exploited SQLite, so I was pretty surprised that we need to get this, like the SQL query and not just the name of columns. What I expected is like that there would be table, like the type would be set to column and I would get all the columns in a given table. That's not the case, it seems, in SQLite. Instead, you get the query, which was used to create the given table. I learned something today. This is pretty cool. Now, what I promised you is to go through basically the exploit that my friend did. So, yeah. Now, one thing to note here is that, yeah, my friend actually did an exploit. Not like didn't do it by hand, because at that point, he was working with an assumption that this is a blind SQL injection, which I also thought this was a blind SQL injection. So yeah, so my friend actually went with this and putting the result here, like select something, and this would return a number. So you get, so it's not really a blind SQL injection because you can get a number back, one number, and the number is limited, I think, like as an integer or as a float, whatever. So how do you get, just having a number, how do you get the flag? How was he able to still defeat the challenge? Let me do word wrapping. And I guess the important thing is here. Like, what he did is he structured the query, right, around classes, as I mentioned, but he grabbed one letter from a given whatever he wanted to leak. In this case, it's a secret, right? And then grabbed the one character from the given position and then changed that character into hexadecimal notation. Now, the problem is that this returns a decimal, and hexadecimal is like 1, 2, 3, blah, 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 8, 9, A, B, C, D, E, and F. These are not decimal numbers, or decimal digits rather, right? These are not. Like, so if one of these would be returned, then yeah, like a fail. It wouldn't work, it would be just truncated probably, and it would be truncated then, for example, for instead of getting like 40, I don't know, 40A for from a character as a ASCII code of a character, he would be getting 4. So to offset that, he actually did some guessing, because only a couple of characters from the flag were missing, so that was enough still to get it. When we discussed it later, the idea was just to brute force it, maybe, because it's brute forceable. And I think we have a script, yeah, there's a script for that, how to do it with like PicoCTF. There's like O and O, let's go here, Python, or rather IPython3. If we look at O, or O, and we look at it in hexadecimal, it's actually 6F, right? So he got 6, but he didn't know what is the second digit because it was truncated, it was never shown. So there are several possible values, and same with other characters. Not a lot of combinations, actually, not a lot of combinations. So with iter tools, you can just enumerate all the potential flags. In this case, it's obvious it's going to be an O, right? But you can, yeah, you can enumerate it, and you can see, this one makes most sense, and then just guess it and put it in, and that's how basically he done it. The other way is to basically, when you have the value, you cannot change it to decimal in SQLite, but you can do some mathematical operations. Like, for example, you can divide it by 2. And or like grab just one bit of the value instead of getting the whole value. Then you just like grab one bit of it, and then next time you're going to do this, you shift it by 1 and then grab a bit again, and so on and so forth. Same technique as you use in blind SQL injection, and you leak the value bit by bit and then just put it together. Now what I really like in his exploit is using this beautiful soup thingy, which I did not know. And beautiful soup is, let's just go here. It's basically a Python library for pulling data out of HTML and XML file. So it's, yeah, you basically give it a website, right? He gave it a website and it parses the HTML for you. And from here, you can just find like ID equal to this and get the value for the CSRF token. Or you can do the same for, what did he do? He automatically got all the to-dos, all the results out of it. So yeah, I didn't know this library. It was a nice surprise to learn that such a library exists, but yeah, just parses HTML and you can quite easily get the data out of it. So there you have it. This is like a second approach to this task that works without when you do not know that, well, when you are convinced that this is actually a more weird blind SQL injection. But as we saw, actually, like this concatenation operator also works, so we had it easier because we didn't have to leak this one by one. We just leaked it like the whole word or like whole string at a time. So yeah, there you have it. I'm going to take a look if there are any questions. Let me close all of this. Okay. Yeah, like in MySQL or like other SQLs, it would be a little easier to solve this task in a blindish way, or like bit by bit or whatever, character by character, because there are like more functions, and SQLite is light, so there are less functions. Let's take a look if there are any questions. Yeah, the questions will appear there, actually. Yeah, well, there. Yeah. Sorry. If you have any questions, you need to ping KrzaQ. KrzaQ is the person who is putting the questions from the chats to my question list. Okay. VMP Protect writes, on stream you use Sublime, but when you actually work with big projects, which editor ID do you use? I use the same editor. I use Sublime, yeah. You can't compile Visual Studio SLNs from Sublime command line. Yeah, I do not work with Visual Studio's SLNs, so that's not a problem. And I do not use Sublime's command line anyway, I just compile from a console. So if I have to work with like solution files from Visual Studio, I just use Visual Studio, but that's pretty rare. I do it like, I don't know, once every 2 years, I would say. So yeah, I use Sublime basically nowadays, and that's it. Before that, I was using Jvim, and it's fine even for large projects. It's like depends what you're used to. I prefer like lean and fast editors to whole studios, but it's a preference. Like you might prefer to have everything in one place, and that might be better for you. That's fine. That's absolutely fine. Okay, you can select each of them. Oh, that was about suggestions. And press Shift Delete. Yeah, I believe there would be a lot of them. Yeah, I could write the script to automate it. If I would write the script personally, I would probably use the... yeah, I wouldn't use Beautiful Soup because that's too fancy for me. I would just do either stupid regexes or just like some string parsing with like split, replace, and so on. And I would use just URL, standard URL. It's called HTTP client actually in Python. Python HTTP client. I might use requests library, but I usually default to the HTTP client instead of doing requests, but whatever you like. And that's it. I don't think any other libraries are needed. So everything which you need is already in the basic Python, unless you want, like, prefer some different way to do it. Like prefer request library, prefer to use Beautiful Soup, or prefer to use something else. That's fine. For closing tabs, right-click, close all on the right. Oh, you mean like somewhere here? Close our tabs. Okay, I didn't know that. You learn something every day. You can use group concat from Daniel instead of using limit. Group concat. Thank you. I didn't know it exists. That's actually pretty amazing. But is it in SQLite? It is in SQLite. Yeah, so that's absolutely a great solution. Instead of using limit and going one by one, we could have used group concat to have it concatenated as one string probably. So that's pretty cool. Yeah, thank you, Daniel. That's a good tip. Okay, let's go with the next one, and it's the forensics. We have recovered a binary and an image. See what you can make of it. There should be a flag somewhere. It's found in blah blah blah. Okay, so just like, do we need to go to the shell, or is it? No, we don't need, right? So I'm just going to download it. Okay. So what's the name? Investigate very free. We did already 2 other tasks like this. The idea is that we get an image. In this case, the image looks the same as it looked before. It's again a BMP, and yeah, and then we need to look at the binary, which is a mystery binary. And the mystery binary is going to tell us how the flag was encoded into the image. We do not have a decoder. We need to write a decoder based on the encoder which we have. Now the mystery file, is a 64-bit binary. So I'm just going to edit it in IDA, or rather open it in IDA. And it's opening. Here we go. Okay, and I'm going to save time. I'm just going to use the compiler. Well, I guess that the compiler is even in the demo version nowadays, so that's fine. It opened the... Yeah, I'm going to use the past tense now, because this was run with the flag to encode the flag into the BMP. So it opened the flag.txt, it opened the original BMP file, and it opened for appending, which is interesting, the encoded file. But so we don't know if this encoded BMP file existed, or did it just like open it for appending. Then it read, what did it read? Like 1 byte from the stream, which is the stream. This is the original. I'll just change the name to original and change the name of this to flag and change the name of this to encode, like output maybe, output. Yeah. Okay, so it read 1 byte. And it put it in pointer. Then it put that 1 byte in until what? This is like, it copied 723 bytes, I guess, because it read 700 bytes and it put them, written them in the output. Okay, yeah, like this is kind of, the order is weird because we have fread here and then fputs and then fread again, but that's whatever, that's fine. Then it read the flag, and then, this is an interesting part, I guess, for 100 times, it checked like if it was an odd number, so like 1, 3, 5, and so on, it would just output the flag. No, it would just output a normal, and not a flag, a normal byte from the file. Otherwise, it would get the bit. Like, I'm saying a bit, I don't know if it's a bit really, but like this is a loop from 0 to 7, like 8 iterations, so that usually means a bit. It grabbed a bit, and then it did something code char, and then it put it in the output, and then it read the original again. It read the original like 1 more time there, so it's fine. And then it copied the rest, like until the end, copy everything. So here, what does it mean that is like a coded character? It doesn't do anything with no, it does something with the pointer. It's probably going to be like list significant bit cryptography, I guess. what is this j? The j, why is it divided by 2? Oh, okay, because like this is odd and this is even, so that's why it's divided by 2. So this is just the index. It grabs it and it also, okay, it's probably going to do, this is my guess, even without looking at the function which we will be looking at. Like there will be, this is like a byte, right? And what it will do, it will remove the bottom byte, like this byte will be removed. And instead of this byte, this bit, instead of this bit, the bit of the flag will be written. I don't know, like let's assume that is 0 in case of the flag. So this will be written here. And I'm guessing we'll have to like just grab this from there. And this is done every second. Okay, it seemed OBS disconnected for a moment. So yeah, let's go to the coded character. Coded character, what does it do? It does exactly what I just said. Like this is exactly what I just said. It takes the third argument, it does a mask with, that's 1, 1, 1, 1, 1, 1, 1, 0. This is FE. The 0 here means basically when this is applied using an AND to anything, then on these positions, whatever was in A3 will be preserved, nothing will happen to it, and the last position is going to get zeroed. And then it's going to be ORed, which means merged with with 1 bit, like this is 1 here from V4, and V4 is nothing else but the flag, which is shifted by it's shifted by A1, which is the index of a bit. So it grabs 1 bit and it merges it on the last position. Typical list significant bit like LSB, this is how it's called, but every second byte, not on every byte, but every second byte. So this is fine. We now know what we need to do, and we need to write a short Python script. So asdf.py, we are going to first read the encoded BMP into memory as binary. So yeah, and I want a byte array out of it, I guess. I think bytes actually in Python 3 operate pretty close to a byte array, but that's fine, like whatever. And this is our data. Now we need the indexes, and the indexes were, sorry, let's go here. The indexes, yeah, this is what I want. I think this is the start index. So like start index, start IDX is 7 to 3. And now for what, 100, right? I in range, but they're using J, let's just use J as well. In range 100, we basically, if like J, if it's even, we continue, we don't care, nothing happens. Otherwise, if it's odd, what we need is we need the actual index, and the actual index is the start index plus J, and the yeah, you know what, I'm just going to do an output as a string. Do I want a string? Yeah, let's do the string. And what we are going to grab is, we are going to append here the data, which is D, from that index, and we get only last bit. So we ended with 1. We are ending it with 1 because 1 is like in 8-bit representation is just like this, right? So all these positions will be set to 0, and this position on the data will be preserved. 1 means preserved in case of AND, 0 means changed to 0. And this is obviously an integer, but we can, yeah, let's just do like str on this. It changes the integer 0 or 1 to a character 0 or 1, and we append it to O. And now we can print O and see what we get. We should get like a nice list of binary stuff. So Python 3, ASDF, yeah, nice binary list. Is this 50? Yeah, it's probably 50. And now what if it's 50, that's actually not good, because 50 is a little bit too much. What's the length of it? 50, okay. The last 2 zeros, I'm going to ignore them. Why? Because then we get 48. 48 is divisible by 8, and we know that each byte holds 8 bits. So yeah, so we need like full bytes actually here. So I'm going to first ignore these 2 bits, because if I would ignore the bits at the beginning, then the number I might then change the idea. But we know that at the beginning the bits are, like, these bits are important, these bits are probably not important, so I'm just going to ignore them. So O is O. Without the last bits, we get only 48 bits from that. And what do we do now? We do magic. We basically make that into a number. So interpret it as a binary number. So we can print that number, and we get this number. This number, we don't care about it. We change it immediately into hexadecimal, and we get this. And this is OX at the beginning. As you can see, I'm going to ignore this OX. So hex, I'm going to ignore that first OX when we get this hexadecimal stuff. And this is kind of short. This is too short. Where's the rest of the flag? Oh well, never mind. And yeah, and now I'm going to change it from hexadecimal. I'm going to change it into bytes, basically. And to do that, I'm going to do a b from hex and use this. And this absolutely does not look good. So there are 2 things which I can do here. After changing it into an integer, I'm going to reverse the order. I don't know what's the order of bits, so I'm just going to reverse it. And it says blah blah blah, blah blah blah, you are not a nice person. So I'm going to change the bit order here. This doesn't look right either, which starts to mean I will have to think about it, and I don't really like thinking about it. Okay, let's just grab this for a second and take a look. I'm going to split it into 8, so this is 8 characters here. Yeah, okay, this is wrong. I already see this is wrong. Let me look here. From 0 to... This is like equal or 7, so that's fine. It is 8 bits. What I don't like here is I don't like this on the position of the topmost bit, because printable ASCII characters do not have a bit set, do not have a 1 on this position. They never have a 1 on this position. On the other hand, if we would say this is actually written backwards, so this is the topmost bit instead, then, well, we have the same problem. There are 1s here. What are these 1s doing here? Which means I did something wrong. And what did I do wrong? So maybe we are grabbing the wrong characters, but might be it actually. We should actually get 1 more or 1 less. So start index, and then it starts going with this. I'm going to add 1 here. I'm not saying it's going to work, I'm just saying I'm adding 1 there. Yeah, because, yeah, maybe I'm one byte off somehow. So let's do this. This doesn't make any sense again, and so I'm going to reverse the string again. And it doesn't make any sense either. So I'm removing this. Am I really grabbing the correct bytes? Is this about bytes? It is about bytes, right? Because each time I'm reading 1 byte from the original file. Okay, let's look at it again. How many putc are called? Putc is called this amount of times, yeah. Then we get putc here. So this is the first is 0. So first we get a character. So I'm pretty sure this is fine. And then we encode this is okay, and we output the character. Okay. We can try to take a look in the binary. We should see the data in the binary. So I'm going to open it in the hex editor. Here we go. We now go to the position decimal, no, not this position, 7 to 3. And yeah, we can clearly see there is some data. Like if we look at the pattern of the of the image, there is like only this stuff here, but suddenly we have some A's here. And this is because the color, which is here, it's like uniform. It's almost uniform color everywhere, but suddenly we start flipping the last bit. So yeah, I'm pretty sure it's somewhere here. In that case, let's go again to the, where does it start? It starts here. And there's like 0, this is, yeah, this is a 0, this is a 0, and this is a 1. And so this looks actually fine. I think we are grabbing it correctly. Let's look at the, okay, so this is the value which is otherwise used, I think. And there are no zeros here, like the colors are actually full, so that's good. We can take a quick look here, and what I'm looking at is like here, if you can see it. This color is 00AOCO. The red color is A02040. The yellow color is FFFE00. And the green color is pretty weird, actually, 20CO40. Okay, so, and that's all the colors, I believe. So yeah, the data is definitely here because no color had a 1 at the end. So we are looking at the right place. Now, why aren't we decoding the data correctly? This is a nice question. And if we, and I will have to be a little more, I guess I'm going to put a little more thought here to figure out what I'm doing wrong. This is getting the this number from the flag. You know what, I'm going to instead go with an output, which is a byte array, which is like, I don't know, let's just go with 100, because whatever, and print it at the end. Don't do it. Yeah, okay. Now, the output index is, so OIDX is j by 2. We know that, right? Now the output index of a bit is going to be... okay, I understand my mistake. Yeah, okay. I thought that this is... I was still having an idea that they are encoding it every... like a bit every 2 characters. This is not what they are doing. What they are actually doing is they are encoding 1 character and then the flag in 8 subsequent characters, and then like data original and then 8 bits. So okay, I had the wrong idea, and this is what the problem is, which is fine, which is absolutely fine. We can so I'm going back to the original idea because it's just easier. So this, we do not care about this. Here, we continue if we do this. Otherwise, what we do is we, for k in range 8, we grab the 8 subsequent characters, but in this case j is it fine like this? It's fine like this. Actually, j needs to be multiplied by 9. Yeah, so it's 0. No, it's is it 9? I think it's 9. Yeah, I think it's 9. First it will be 0, so this will be 0, and then we are starting from 9th. Okay, that's fine. So start index plus this was like 8 plus 1, right? 1 is here, 8 are here. And then we get a bit. Okay, and now it looks fine. Now I like it. This is absolutely incorrect. Why is it incorrect? Because I forgot to put plus k. This is better. Hello there. Okay, if this is better, then it's still not perfect, but it's better. Let's see what's the length of this. So print the length of this. Okay, this is divisible by 8, so this is fine. So now we do the same thing which I did. It's like we grab the O and we change it to a number. Immediately we switch it to hexadecimal, and we ignore the OX at the beginning, and then we do bytes from hex and this. and then we print it. And we got a non-hexadecimal number found. How did you do that? No, like seriously. Okay, this is fine. Oh, this looks absolutely hexadecimal. It looks wrong as well, but it looks hexadecimal. I'm going to, in that case, again, like go from the end. This looks a bit better. Yeah, way better actually. Yeah, I just like flipped the bits around. Okay, and we get what's... Does this look like a flag? I wonder if they got a full flag. I don't know if it's a flag. No, okay. Yeah, I see what's happening. We are missing some characters, folks. Because it's like PC, that's PicoCTF is missing, F, and then the brackets are missing. So we are missing one character somewhere. Why are we missing one character somewhere? I think I'm just going to like change this a little bit. Start index, then for, in this case, just progress the index by 1. Otherwise, we don't progress the index, we progress the index, I'll just do like IDX here. And after using the IDX, we progress the index by 1, and we do the same. Okay, that's better. Not perfect, but way better. It seems to be split into 2 parts for some reason. I'm just going to reverse the string which I have. Okay, PicoCTF, and yeah, that's fine. That's the flag. I had some mistake, some weird mistake here somewhere. Yeah, okay, that's correct. It's solved. Perfect. So I guess this is like the construction which might be confusing some people, but if you probably see this like for the 100th time on my live stream. It's the easiest way basically in Python to get bits and convert them to actual characters. You can do it manually by grabbing 8 bits at a time and then putting that into a value and doing CHR on it. CHR actually, yeah, like without this. But this is just like faster to write. And this is because the order of bits is, there are 2 ways to encode bits into bytes, right? You can do it from the start to the end or from the end to the start. And therefore you basically do insert this if it works, or like remove it if it, maybe that works. That's the idea. I don't like thinking about which way the bits are encoded or checking it. I'm just going to try both ways. This is what I'm doing here. Now at the end, I have to reverse the string, because if you convert a series of numbers, a series of bits, to an integer, well, the first bit is going to be the most significant one. But at the beginning, we have the first character, and the first character is actually like at the beginning of the flag as well, right? Yeah, but if we convert it to a number and then that would be fine. But if we do this here, that means that the first character actually goes to the end of a bit stream, and therefore we have to again bring it to the front by reversing it again here. So this is basically tied. You put one, you have to put in the other. And yeah, that's it. Like, yeah, play a bit with it. It's just like again a cheat to do a conversion from bits to a string in a Python way. And yeah, you probably are seeing this for the like 10th or 100th time on my live stream, because I'm usually using it. Cool. Let's see if there are any questions. on a real CTF, would you hammer on a chosen method or swap to a different approach? Like now we see, now we've seen 3 methods. I guess I would approach exactly the same way I'm doing now. As in, I'm usually going after the method which I like the most at a given point in time. So if I find like my method is not working, so I like my confidence that that method is starting to drop, I'm going to switch to another method which is like has higher confidence. And if like nothing works, then I'm just going to look at the task again and figure out what I'm doing wrong. Okay. You have to mention KrzaQ if you have any questions, ideally with @ sign. If you cannot, then just like, yeah, if you have problems with mentioning KrzaQ, refresh the chat. What's my main operating system? I see the question in the chat. My main operating system is Windows 10. Though the console which you see here, for example, that's a Linux console. Like if we do cat etc issue, you will see this is a Ubuntu server. Actually, that's Ubuntu server 1910. Is this? No, it's not Linux. Okay. Yeah, because I have, yeah, it's a long story, but I have a VM with Linux basically. Okay, then we have another reverse engineering challenge, and we have web exploitation again. And we have what? 13 minutes. Let's do another binary challenge in that case. There's one more question. Okay, let me show you the questions actually. I think it's a good question. Rise Gunvale relied completely on the pseudocode generated by IDA. Is it a good practice? I mean, is it always 100% accurate? A great question. No, it's not 100% accurate. It speeds things up. It's usually fine to look at it. If you have doubts, then you start looking both at it and assembly. If you have doubts, but like a lot of doubts because you think it's actually like misinterpreting the code, or the code is like super complicated and it just has no idea how to, like you just see gibberish basically after the compilation, then you just focus on assembly in that case. But it's still faster to do it with some kind of high-level code representation if you have that available. So that's the default, and then you go lower into assembly if that doesn't really work. And there are cases on real CTFs, almost on every CTF, there's a binary which, like, some parts are just like lying to you, like the compiler is lying to you. But you can figure that out. Like, just remember that it's not flawless, but it has issues. But it's just like heuristics basically working there, and you'll be fine. Is Ubuntu Server lighter than the client? So the reason I'm using Ubuntu Server instead of Ubuntu Desktop is basically because it doesn't install the X server and the X desktop environment by default, especially that I don't need it because I'm using X server on my Windows machine. So I have a VM which communicates to the X server on my Windows machine. So I absolutely do not need the desktop environment, and that's what I'm using the server. That's like basically it. Why don't I move to Linux? Because Total Commander and because games, basically. Yeah, like these are the 2 reasons. And no, Double Commander, Genome Commander, Midnight Commander, and other commanders on Linux are not as amazing as Total Commanders on Windows, I'm sorry. Okay, let's go with this one. I'm going to create a new directory though. Yeah, same story. We get a binary and we get 5 images in this case. And we have to somehow find the flag. Okay, so the images are... Is anyone surprised that the image still looks the same? Yeah, I thought so. I'm not surprised either. Let's take a quick look at what is the binary about. Gaming with DXVK is pretty good now though. What about mouse drivers for eSport grade mouse or mice? Like I have a Razer mice here, you cannot see it. Here I have a Logitech mouse for another one. Both of these have their own drivers. I also have a keyboard which needs a gaming driver. So yeah, there's that. Yeah, so the mouse and keyboard drivers is another thing. And also, I'm not sure, like, for example, how well would I have a monitor with G-Sync, which means it has like variable refresh rate. It's basically waiting for frames. Like until the graphic card sends the frame, it keeps the old frame, and then when the graphic card sends the frame, it refreshes. So I'm also wondering how the drivers on Linux actually support it correctly. I'm a little bit afraid of that. Which games do you play? Apex Legends at this point, mostly. Okay, let's put it in IDA. It's again 64-bit binary. And I tried to switch into Linux desktop multiple times. I have like a lot of computers on Linux server, like server computers with no keyboard, no screens, and they operate on Linux, and I'm super happy with them. I always had stability issues, or like some piece of equipment didn't work on Linux desktop for some reason. So maybe someday. Okay, let's take a look what's here. Okay, if there's a flag, then encode all. Okay. Then we have this. What am I looking at? Hexadecimal characters. What am I looking at? Item 10C. What is that supposed to be? Can I look like item? Is there some item string here? Okay, then it grabs what? Encode data in file. But what's the string here? Let me just decode it. It's item 10 C P BMP. Why is it 10? I have only or is it like, sorry, that's not 10, that's 01. Okay, so that's item 01. And okay, now I get it. So this is item 01, and let's just go back here. And here it actually probably changes the character here from between 53, that's going to be 5, down to 0. Yeah, so it changes the characters down to 0, but it has to be larger than 0, so it's like 5, 4, 3, 2, 1, and we indeed have, like if we list it, we indeed have like 0, 2, 3, 4, 5. Okay, so it calls this function multiple times, and what does it pass to the function? It passes to the function this and this, like, it's the same, right? This is like item BMP, the same. I don't get it. It seems it passes like the same name of file twice for some reason. Why is that? And then there's encode data in file. Maybe it's like are different files or something, I don't know. It opens for appending, it opens the second file for appending to, for reading appending, I guess, I don't know. What is RA? That doesn't make sense. It was like reading and appending. I don't get it. Maybe like it's the compiler acting up. Okay, then we read. We do basically the same stuff which we have seen in the previous one. What's the difference? Okay, the difference is the offset. Like 2019 is the offset. And then every fifth, there are like 4 characters. No, so that would be 0. This goes here. This is 0. Then 1, 2, 3, 4. It goes into this part. So it just copies 4 characters, and then it copies, like, does the same. So this is like pretty similar to the previous one. I guess the flag is a little bit longer here, and it's split into multiple files because of that. Where does it get the flag from, by the way? okay, the flag is put in the, this is like a global registry, and the flag index is being income. Okay, so it's just like the flag is just split into several files. We do exactly what we have done in the previous task. I'm even going to copy the exploit, and instead of this, instead of like having one data, we are now having 5 files. So yeah, I know I should just create a function for that, but because this is like a CTF environment, I'm just going to do this. And it's called item. Let's change the name, and here 3. And it starts from 5, so it starts actually from the end. Do we care that it starts from the end? I don't know. Let's just keep it like this for now. So we have the data. Now the index is this one. Here what we change is actually we do this. And we have like several data files. So what we do, we need like another loop. Let's call it like data, maybe. And here do d and data. So we iterate through each of these files. Then we, for each of them, the index is actually here. Okay, we put the index at this point, we do this, we grab. Does the encode do the same thing? Or does it do something weird? No, this is the same function. It's again like just switches the last bit. And then we do this. Okay, let's see if this works. If it doesn't work, I'm going to go from the end on these files. Python 3 ASDF. Pico, then a lot of zeros. Okay, it actually worked, but what I'm going to do is I'm going to put it in like F, like flag, right? And I'm going to do F equals F replace. I don't care about the 0 bytes at all. I'm just going to remove them, and then I'm going to print it. And it says byte replaced for the this B, because Python 3. Yeah, that's it. Like, yeah, that was a super easy task. They just did the same, but what we had to do is like add a couple of more files and change the index, and that's it. So it was almost identical to the previous challenge. No magic here, done. Okay. Yeah, that was actually fast. I didn't expect it to go so fast. Let's take a look if there are any questions. What are the next challenges? There is a web security challenge, another web security challenge, another web security challenge, and binary exploitation, more reverse engineering. The name of the game is Speed. Are you quick enough to solve this and keep? Okay. Binary exploitation, reversing. This is going to take some time. In RSA, D is a lot bigger than E. Why don't we use D to encrypt instead of E? Okay. That's some fun crypto challenge, I think. Binary, a lot of binary exploitation. There's some ROP. I really like ROP, so that would be fun. Then Java, more Java. Let's do the Java one immediately, because Java ones were super simple. Value door 7. Oh, Empire 2. That's interesting. Okay, let's do this one. Sorry. Oh wow. That's a lot of text. Each character can be represented. Okay. Since 4 characters can be represented as one int, the 32 can be represented. Yeah, this works okay. Okay, well, yeah, again, this is pretty easy. Like, based on this, they just, like, concatenated all the characters into this. It's just what we have to do now is the subset of what we did a second ago. So I'm going to create a asdf.py, I'm going to create a new console, and I'm going to copy the characters, and we are going to do it like super fast and efficient, and it's absolutely going to be simple. And let's see how long will it actually take. Let's do this. Okay. Here now I need this d equals here. Okay, so for, let's do O as output. For K in D, we change D into a hexadecimal value, and then we remove the OX, which is at the beginning, and we do the B from this needs to be binary, from hex, and we put this in, and we append it to O. We do have to change the order of it to be the other way around, and we print O, and I think that's going to be it. -3. List, not DK. This is I don't know. Let's see if this works. If it doesn't work, then we'll figure it out. Not incorrect. Okay, so that means I have the order of something wrong. Maybe I don't need this actually. Yeah, I didn't need that in this case. A bit of bit shifting. And that's it. So actually, like, this task is super simple if, and only if, you understand that a number has a value and that value can be represented in different forms. But the number still stays the same, and the forms are like derived from the number. If you understand that, this is super simple, and it's not trivial to understand that. Actually, I've written a blog post, like, I think it's in Polish, but I have it translated to English. I just need to publish it. Yeah. I've written a blog post about it, which has like several pages just to try to explain what I just told you. Is that, yeah, a number is just a value, but that value can be represented in multiple ways. And if you, I know that a lot of beginners, especially beginners in programming, focus on the representation way too much. Like if they see a hexadecimal representation, they do not associate that with a decimal number of the same value, or like octal number of the same value. It's a different thing, a different concept for them. And yeah, so here this task is might be problematic for them, because what I see here is I see a value, and I know that this value represented in hexadecimal will actually can be converted easily to bytes because of properties of hexadecimal and so on. This is super easy, but again, you have to know that. So if what I did is super confusing, I will try to publish that article in English soon, maybe this week, so you can try to wrap your head around it. But this is again something that people who are only starting with have problems. If you're intermediate, you probably already, you don't have any issues with this. And the same is with the trick which I'm using with the, you know, switching the binary into an integer, into a hex, into then flipping like the other way around. This is the same kind of understanding of numbers and the representation you need to have to be able to understand that trick. Yeah, cool. Okay. We have a few more minutes, so I'll answer a couple of more questions, and next time we will go with another challenge. I'm looking like there's like forensics. Oh, encoded one. So I guess this is something different. Another one. Are we going to do that? We are absolutely going to do this one too. Valued or 8. And let's take a look what's going on here. Okay, so it's obfuscated. What you do is you Java pretty print, pretty fire, or online formatter, doesn't matter. Yeah, you put this here and you do, what do I need to click? Beautify. Okay, and it's beautified, so I'm just going to copy paste it. Yeah, now we can read it. It's a little bit longer, it seems. It uses some scramble, which is what, shuffling bits around, I'm guessing. Can we wrap this? Switching bits. It's checking the password. Okay. So what's going on here is we enter a password, and then this is called the check password. What the check password does, it scrambles the password, so it does something on the password, and then it compares it to this value. Now the scrambling is thank you for the donation, Michał. We want Total Commander for Linux. Yeah, I absolutely want it. It's on Android, right? But it's not on Linux. What the hell? Yeah, then we have switching the bits. I'm checking if there are... What are they actually doing here? What's surprising to me here is that they're operating on the first number. They're like... Oh no, because this is swapping the bit position. Okay, I was thinking of copying the bit, but it's swapping. So this is fine. Okay, what we have to do here actually is okay. I'm going to cheat here. I'm going to do edit permute lines reverse. And that's one thing. And then what I'm going to do here is I'm going to do scramble on expected. This is scrambled, and now I'm going to output it. How do I output something in Java? I have system perfect. Scrambled. Okay, and now I'm going to compile it. I do need a console to compile it. Java C vault door. Cannot be converted to string. Where is it? Scramble. Yeah, last time I written in Java, it was some time ago. Java char into string. How do you convert it? No. Method 1 is new string. Oh, we just do the new string. Okay, let's go. Here we do this. Okay. And it says that it doesn't like us because here. Because, okay, yeah, like just whatever, just pass the password here. B next, I have no idea what that does. B, see, what is my, like, that absolutely does not matter. Just like, yeah, this is not needed, we do not care. Just remove it, goodbye. Okay, done. Okay, yeah, that's it. Yeah. Sorry, it took longer than it should because I do not remember Java. I coded in Java even like professionally, but that was a long time ago. Yeah, basically, like the whole weakness of this is that it was enough to reverse this line and recompile it, and you had the flag. That's basically it. Because, like, if you have a string which is encoded, to decode it, you have to apply the same operations in reverse. Assuming that's possible, it's not a checksum, but like a hash, but it's actually just encoded. You do the same operations in reverse. It might be super hard to reverse an operation, but switching bits is reversible. The only thing which we need here is the order. So that's why I permuted the lines upside down, and then instead of putting the password there, I put the expected value there and run it, and that's it. Yeah. So one note here: if you did this challenge and you did not figure it out so easily, this is because I was cheating, and I was cheating by having experience in a lot of reverse engineer challenges which followed the same exact scheme. And yeah, I remember times like in what 2008ish, 2009ish, when on some conference on a KrzaQ competition, I done exactly the same thing with like 200 lines of assembly, and it also solved the challenge. So yeah, that's like, it's kind of cheating by experience. But yeah, like I guess the solution was by finding the weakness and like abusing the weakness, and that's it. That's done. Cool. Now the questions. Yeah, and we are just in time, I think, for the questions. There are no questions. Okay. I'm going to take a quick look at the chat if there are any questions. We could play some Apex for sure. Is that Apex on Linux? If you're playing Apex, by the way, and you're in the like Central Europe servers, we have on our Discord there is a games Let's Play Together channel, and yeah, there are some people who also play Apex or CS:GO or other games, so just join and stay, and we might play someday. Why not dual boot Windows and Linux? No, dual boot is painful. Like my computer takes to reboot a couple of minutes, and okay, it's because it's actually testing the RAM. And testing the RAM, I have 128 gigs of RAM, and that takes a bit to initialize. So yeah, rebooting just to play a game, that would take like a couple of minutes, and then again, no, but that takes too long time. What I would consider is like, and this is what I've done in the past, I just had a second machine. I might just get a second machine, which I'm again considering because I wanted to play Valorant. I even got into the closed beta, but it turned out that the anti-cheat they have, which is pretty aggressive by the way, doesn't really like my sound card device, like virtual sound card, which I do have installed because I need it for live streaming, so like this live streaming, right? So I'm considering getting a second machine, just like putting my GPU into that machine, getting some cheap GPU to this machine, and maybe that will work. Okay, there's actually a question, so I will show it here. If you have a question, ping KrzaQ, like this guy, because he will put the question on my panel. VMP Protect writes, is malware analysis interesting? I'm applying for a malware analysis job, and I usually like working with the obfuscation, devirtualization, exploit development, malware analysis sounds kind of boring. Yeah, so it's like this. It depends. Most malware which I analyzed when I was working with malware analysis was boring. Like Delphi, Visual Basic with some commercial obfuscators, which was like super easy to defeat. After you've seen one, you've seen all of them basically, and that wasn't super interesting. Yeah, sometimes you get a gem, which is fun to analyze and it's pretty cool. So yeah. Thank you for the donation, Michael. Loving these videos. Looking forward to the next one. Thank you. Next one is going to be next week. Now, yeah, so malware analysis can be fun, but it can be also boring and tedious. So it really depends what kind of malware you're analyzing. Are you going to analyze like new, like top malware which just came out and nobody saw before, which is using 0 days and is using like cool obfuscation techniques? Or are you going to go with like the general stuff where like, you know, a person buys on the darknet some generator for bunker Trojans and puts like a lot of BMPs there, and then like sends that Trojan around, and you have to analyze that? That's way more boring. So depends on what you'll be analyzing. Yeah, it's always fun if you have the ability to dig into a sample and analyze it really thoroughly. Bringo asks, have you thought about some BSD Linux kernel exploitation on live stream? There aren't many videos showing it live, only talks about how someone exploited it but never the real deal. I'm trying to remember last time I played with kernel exploitation, but that was a long time ago, and I don't believe I ever played on Linux with kernel exploitation. I only played on Windows. So I wouldn't expect that, actually, unless I, for some reason, am going to play with kernel exploitation on Linux soon. Then maybe. Regarding the question about malware analysis, I have to work with IoT malware, BIPs, and ARM. That might be actually more interesting. That's my guess. It might be more interesting than the desktop stuff. Yeah. Because there will be like a lot of, but it's not like there will be a lot of malware which isn't just like press enter and you infect yourself. Like these are probably going to be tied with exploits. So it might be more fun. Okay, I think that's about it. Let's reverse Vanguard. That will be interesting, but yeah. Cool. Let's finish it for today in that case. And we are going to see each other tomorrow if you speak Polish. There is a slight chance tomorrow might be cancelled, depending on how my schedule actually works out tomorrow, because it's pretty tight. Otherwise, we see each other next week, and we have the next episode of PicoCTF. We still have several challenges to solve. There were 21 at the beginning of today's stream, and now it's 21 unsolved still, because that's how PicoCTF works, it seems. So see you next week. Have a happy day, happy evening, happy week, and happy hacking. So thank you to my moderator, and see you next time. Bye-bye.